Hey folks, this is going to be the second video in section 6.5, and it will cover a few examples of tangent and cotangent graphs. So let's go ahead down to the how-to gray box. And one question that was asked here that I did not cover in the first video was, when looking at one period, just from 0 to pi of both parents, how do you describe the location of the asymptotes? And if you're only looking at one period of tangent, the asymptote is in the middle, and if you look at cotangent, it's at the beginning and the end. And then where would you describe where the x-intercepts are at tangent? It's at the beginning and the ends of that period, and for cotangent, it's in the middle of the period. Some guidelines for sketching. The first thing that you want to do is use your little formula here to find the period. So it's going to be pi over your b value, and then mark it on the graph. And then you also want to mark the second period, because usually you are asked to graph 2 full periods. Step number 2, take that 2-period interval and divide it up into 4 equal parts, similar to the way that we did for all the 4 other functions. Sketch the vertical asymptotes. Tangent asymptotes occur at the quarters, cotangent at beginning, middle, and end. And then use the center to find the x-intercepts, center of the asymptotes to find the x-intercepts. Tangent x-intercepts are at beginning, middle, end. Cotangent are at the quarters. And then you would just want to join with a smooth curve approaching the vertical asymptotes. Tangents increase, cotangents decrease, and then indicate any additional periods if necessary. So let's go ahead and jump into a couple of examples. When I'm looking at y equals tangent of 2/3 x, my period is going to be pi over b. So pi over 2/3, when you multiply by the reciprocal, is going to be 3 pi over 2. So what we're going to do here is let's just mark 4 equal intervals. And the first period, which is going to take us to the middle, is going to be 3 pi over 2. And then if you double that, 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, which is the same thing as 3 pi. And then if I take 3 pi over 2 and multiply it by a half, that's going to be 3 pi over 4. And then all I have to do is count. So 3/4, 6/4, this will be 9/4, and this would be 12/4, and 2 of those will reduce. So this is going to be 9 pi over 4. So 3, 6, 9, 12. This is a tangent. So that means that my asymptotes are going to occur at the quarters. And my x-intercepts are going to occur at the beginning, middle, and ending. And tangent is one of those graphs that goes uphill. It's increasing. Usually, like I said, you're asked to graph 2 full periods. So those 2 are identical. And there's the rest of the first period, and then I'm going to duplicate that for my second period. All right, let's go into example number 2. So for example number 2, notice that the negative is going to cause me to reflect over the x-axis. Quite frankly, we don't have amplitudes, so the 1/2 isn't going to make a huge deal on your drawing. So just understand that. But the b value will make a difference. So first thing is, let's reflect it over the x-axis, and then pi over my b value is going to be my period. So once again, let's mark 4 equal intervals. Pi over 2 is my first interval. Pi over 2 doubled is going to be pi. Half a pi doubled is going to be a whole pi. Half of that first period is going to be pi over 4, and then I can just count 1/4, 2/4, 3/4, and 4/4 for the last one. Again, it's a tangent graph, so I have asymptotes at the quarters. Normally it would be going uphill, but because this has been reflected over the x-axis, I'm going to be decreasing. All right, now let's take a look at example 3. So this is a cotangent example. Again, the 3 out in front, the amplitude, you're not really going to be drawing anything that makes that look different. There is no amplitude because it goes up and down forever and ever. It has an infinite range. But my period will be pi over 1/2, which is going to be 2 pi. So let's, again, mark our 4 equal intervals. The first period will be 2 pi. If I double that, that'll be 4 pi. So this is going to be 1 pi, 2 pi, 3 pi, 4 pi. This is a cotangent graph, so my asymptotes are going to occur at the beginning, middle, and ends. Again, x-intercepts occur in the middle of asymptotes, and since it's cotangent, it is going to be going downhill. It's going to be decreasing. Okay, let's go ahead to example number 4. So once again, we're looking at a tangent graph. Really, all this is the tangent parent that has been shifted down 3 units. So the period is just a normal pi, and we are shifting down 3 units. So let's mark our 4 equal intervals here. The first period is pi. You want to double that to get 2 pi. So we have pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. This is tangent, so my asymptotes are at the quarters. And if you think about even shifting a vertical asymptote down, it doesn't look any different than what it looked like originally. What is going to be different, though, if your original x-intercepts were on the x-axis, hence the reason we call them x-intercepts, we want to shift those down 3 units. Again, this is a tangent graph, so we will be increasing. Okay. And then the 5th example, and we're going to throw in quite a few things on this one. I'm not sure what your paper notes may look like, but I did shift the y-axis on this particular graph. I might have fixed that on the PDF. I'm just not sure if I did or not. So just be aware of that. All right, so a couple things here. First of all, there is, my B value is 1, so this just has a standard period of pi. My phase shift is going to be going to the left, pi over 2. And I have a vertical shift that's going up 3. All right, so the first thing that we want to do, this is like we did for the other trig functions, is let's graph what it would look like pre-shift, and after we graph that, we'll pay attention to the 2 shifts. So before the shift, let's go ahead and mark 4 intervals. And the first period is going to be pi, so then the second period will be at 2 pi. So we have pi over 2, pi, 3 pi over 2, and 2 pi. This is a cotangent graph, so I'm going to draw my asymptotes very lightly because they are going to change. So remember, with cotangent, we have beginning, middle, and ending asymptotes. Okay, so again, I'm just kind of sketching these in here so I can see where they're going to move. And our x-intercepts would have occurred at pi over 2 and at 3 pi over 2 at the quarters. Now what we want to do is we want to shift everything to the left, pi over 2. You notice here that pi over 2 on my graph is 4 blocks, so everything is going to shift to the left 4 blocks. And then we also want to go up 3 blocks. So let's go ahead and mark 3 on our y-axis. So everything shifts to the left 4 blocks and up 3 blocks. All right, so here we go. The first thing that's going to shift is that first asymptote, and I'll do this in a different color. That first asymptote was on the y-axis, so let's go left 4 blocks. It doesn't matter if I go up or down because that's just my asymptote. And I'm going to go ahead and shift all of my asymptotes at the same time. So the middle asymptote, left 4 blocks, and the ending asymptote to the left 4 blocks. And then I'll take my x-intercept. So this guy is going to go to the left 4 blocks, but it's also going to go up 3 blocks. So my new, it was my x-intercept. It's not going to be an x-intercept anymore, but is going to be right there. And this one was an x-intercept, so we're going to go left 4 blocks and up 3 blocks. Again, this is a cotangent graph, so it's going to be decreasing. And there we have 2 full periods of this particular cotangent graph. All right, that's the last example that we have for this particular section.